Stept.
Cool. So thanks for coming out tonight. So I'll be talking about framework-agnostic web applications. By the way, before I start, I just want to say that I'll be putting slides on Twitter. We can also discuss further on there. So let's start. So maybe this word is a little bit weird in the beginning, so I'll just start by trying to define it. And when I start looking at it, I found these weird definitions, like agnostic as a unwillingness to commit to something, to an opinion or something about something. But I later found this definition, which I found that applies much better to software engineering, and it's like this. So an agnostic system is a system that is compatible with many platforms or operating system. So for me, agnostic is exactly the second one. So when it comes to framework-agnostic web applications, my definition is that they are applications that are designed so that they are not tied to any particular framework. So why I think this is important, and two things. First one is it's about the web, right? So we all know the web, we all love and hate the web. So this is like a chart of like web technologies in the last 10 years. It finishes in 2015, but here you can see things like, I don't know, DOM libraries like jQuery or Dojo, or like CSS libraries like Sass, Modernizer, Bootstrap also. You see also frameworks to help us write better applications like Backbone in the beginning, but also Angular and React, and later recently Vue or Polymer. But there's also things that help us write tests like Jasmine or Karma, Jest, Ava. Things like dependency management, so NPM and Bower, which is now dead, I think. I think these guys in the front will know more about it. There's also tooling things like Grunt or Webpack or Browserify or Yeoman, so things that helps us bootstrap or compile our projects, so more in the tooling space. Also things like transpilation, and this is like a weird word in Portuguese somehow, but like things that help us write code in, I don't know, in a modern way and then let it compile to older browsers. So, and you can see like there's this trend, right? It's like, it seems that every year there's more and more technologies that appear. So every year there's like this JavaScript fatigue that I'm sure you all heard of. I mean, it's on all over the internet, like imposter syndrome, JavaScript fatigue, what it feels to learn JavaScript. I think it's better summarized by this, I think, fake book, right? So it feels like today front end is about rewriting your code every 6 weeks somehow. But I mean, the news is this is not going to slow down by any means, right? So this is a real chart of NPM modules over time, so we can expect the JavaScript fatigues to only increase over time. But I don't think that this is necessarily bad, right? I mean, with new tools, we also help us write better code and with more ease, and we just have to get used to it, right? So we have to think about code as a changing thing, right? So we have to code, write code that is agnostic to all these evolving tools. And this is why I think framework-agnostic web applications are quite important, right? Because it basically allows us to write code in a framework-agnostic way, and then later down the road, when we do have to rewrite our application, like every 6 weeks, maybe it's not that hard, or I don't know, at least it's a little bit easier. So again, this is my first point. I think this is really important because the web moves faster than we can ever learn it, and I think that's okay. So the second point is this one I want to show you, and this is basically how we developers judge frameworks, right? We write these benchmarks and we go have these, I don't know, pointless debates of which one is better. I mean, at the end, our users, like everybody else that is not a developer, everybody else outside this room, they couldn't care less, right? they don't give a shit. Like they just want to use tools and they don't really care what we use to do it, right? And I think the perfect example is just have a look at some common websites, right? So there's this Virgin airlines website. When it came out a few years ago, was one of my favorite websites, and it just happens to be done in Angular 1. People seem to love it. There's also this one very popular in Asia. It's called Elime, I think. My Japanese is rusty. Anyway, it was done in Vue, but nobody cares. And then Netflix, which is, I guess, for me, like my favorite app right now, and it just happens that it was done in React, but nobody cares. So I think we should focus more on building great products rather than having these pointless debates which framework is better. Doesn't really matter at the end. And building great products is actually quite hard, right? I mean, users will judge you on how your views look like, how our routing is done, what happens when I click here, how do I create and update data, do we do optimistic updates, do we have data consistency, you get it, right? So this is what people actually cared for. So which brings me to my second point, why I think framework-agnostic web applications are important. It's because users, they only judge you on your product, and that's pretty hard on its own. Cool, so here I'm just trying to create a new word, but let's try to see how we can actually build framework-agnostic web applications. And the answer for this, or one of the answers, I think it's with Redux. So let's just jump right into it. So Redux, and if you read the Redux docs, is a library to manage state of your application, which is kind of weird. But for me, it's more like your framework-agnostic best friend. But let's see why. So Redux apps, and again, this is from the docs, they run on different environments, right? And again, this is good because the web moves fast. So if we can write code that runs on different environments, that's pretty cool. The other thing is because it behaves consistently, and it's very easy to test Redux applications. And again, this is quite important because writing good applications is actually quite hard. So if it is a way to make it easier, that's cool. So I just want to talk a little bit about Redux itself. And it might sound very complicated, but it's not. So in reality, we just have to understand these 4 concepts. And I will introduce each of these concepts. And the Redux part is the top part. That's the framework-agnostic part of your application. And these you can write like to last, right? This part won't change even if you change your framework, right? So the idea here is that you are free to change your framework over time, and you probably will. So every 6 months or 6 weeks or whatever, you can just change the bottom part, and you kept all the rest. So let's just start. This will have a lot of code, I'm sorry for that. Cool, so let's just start with the Redux star. So Redux is just a module that you import like this. One of the methods it has is this create store. So what is a store? So you create it like this, quite straightforward. And once you have a store, you can do things like get state, which returns just an object. And state is basically, it handles everything about your application, right? So everything in your application, it should be looked at as state. So for instance, if you're looking at Twitter, and I highly recommend this blog post where one guy tried to dissect their store. Everything on Twitter is in the state, right? So the tweets, the users, lists, your timeline, your settings, your notifications, everything is in the state. The other thing you can do with the store is subscribe to changes, right? So someone will change the state of your application, and the store is just a way to subscribe to these changes. So you also have this method called subscribe, and you pass it a callback. The last thing you can do with the store is dispatch an action. This for now is not very clear what it is, but it's exactly the next part. So let's look at actions. So actions are just an object, right? So a store is kind of an object that you can call different functions onto. An action is just an object, and it always has a type and a payload. So it looks something like this. So when you dispatch an action, you're just calling this method with this object. One thing that is also quite important is this concept of action creator. So while the action is this object itself, it's quite common to have this object creator, right? So it's just a function that returns a dynamic action. So let's say if you have an action called rename to-do, of course, you might have to pass the index of this to-do and the new name, and that's how you can have a new action being generated. So you might call it like this, store.dispatch, and then you call this action creator, and it will dispatch this action. So I think it's simple until now, right? Let's go into the last concept, which is reducers. And this is probably the hardest to get. So while actions that they describe that something happened, right? You want to rename a to-do, or you want to add a new to-do, or remove a new to-do. A reducer knows how to react to these actions, right? So an action doesn't know anything, but the reducer does. And the signature of a reducer is basically it's a function, and it's a pure function. I don't want to get into the details, but it basically receives the previous state and the action, and it's responsible for returning a new state. So in case of the rename to do example, it would return a new state where the new name is changed. But on a smaller example, you can have a very dummy reducer like this that simply increments a given number, right? So you can have an action of type increment, and here you just increment the state by 1, or you can have an action of type increment by, and you increment by the payload. One thing to notice here on the right side again is the action. Here is just syntactic sugar to deconstruct the action, because we've seen that the action is an object of type and payload. So a reducer looks something like this, not the prettiest function in the world, but at least it's pure. That's cool. Cool, so let's say if we have this counter reducer, we might call it like this, right? So if we have the current state of 0, and if we call an action of type increment, the counter reducer would return 1. And if we have the current state of 5, and we call the action increment by, the reducer would return 6. And notice this is quite nice, right? Because you can basically unit test all your logic. Like if all your logic is done in a reducer, it's a pretty easy way to test everything. Cool, so that's the basics of Redux. It's not too hard, but it might be a little bit fuzzy how to use it, right? So for this, I have a challenge. This is the first challenge. There will be 2. And we basically will try to write a Redux application in both React and Angular 2. Yeah. So again, what we're trying to build, we will first look into the Redux part, write our actions and reducers and our store. And then the React and Angular part will come with the component bit. So let's first start to see what the app we are doing. It's just a to-do app, very wireframey in this case here. So step 1, to build a Redux application, you have to think about the state, right? Like you have to design your state. So the state in this case, I think, could be something like an array, right? A very simple state. We just need an array of to-dos. Each to-do has a name and its completed value, and the state that you're seeing right now is equivalent to this state on the right side, right? So they are equivalent to what this is on the object form, and this is just in the UI form, but it's the same state. So the step 2 is to think about what actions we might want with this app. I'm not writing all of them, but I think we could have things like an add to do action, and we can have a toggle to do action. So the first one is an action creator here. You can see add to do, that we receive the new name, and we just dispatch this action, right? The second one is a toggle to do that receives the index of the to do and just dispatches this action. We still don't know how our state will react to it, because that's step 3, right? So let's have a look at the reducer. So a reducer for this app might look something like this. We have a to-dos reducer. Again, the state, we are initializing it to empty because we want to start with 0 to-dos. And then we receive the action in the second argument. And whenever we get an action of add to do, we just concatenate this new to-do to our state. On the other hand, if we have an action toggle to do, this syntax might look weird in the beginning, but basically we are just changing the to-do at index. You can look at this code better, but it looks quite straightforward, right? So the last step is to create the store, and this is quite easy actually. We just create the store. I forgot to mention in the beginning that this create store method actually receives the reducer as an argument, and that's all it does. So here we just create a store, and we have a callback that subscribes to changes. And what I'm doing here, like this last line render, that's the framework part, right? So that's what the framework does. It receives a given state, and it renders an UI somehow. Like on a generic term, that's what frameworks do. So we're not looking into that right now. So when the user types buy groceries and clicks the add, we will somehow dispatch this, right? We will call store.dispatch add to do buy groceries. The important bit is this one. And whenever this callback runs again, because our state changed, we will just get a new to-dos here. You can see now that it's not an empty array, and we will just render this new to-do. Again, if we dispatch another to-do, go to gym, the callback will fire again, and will look something like this. If we now toggle the to-do at index 1, that's the result on the right side, right? So it's just marked as completed. So the missing bits here are the framework part, right? So again, this render function, which generically is just a function that receives the state and returns some kind of HTML or something. And then the second bit is actually the thing that connects the click on the button and that dispatches the action. So this is the framework part. So let's try to integrate it with these two frameworks, right? So the slides, there will be a lot of code right now, and I'm trying to compare React and Angular side by side. Not because one is better, it's just to see how much of code we can reuse. So the React slides will be the blue one on the left side, Angular slides will be on the right one. So let's start with React. So how we connect Redux with React looks a little bit like this. I will dive into it in a bit. And in Angular, it might be a little bit like this. So let's just dive into it. So parts of this code are to bootstrap the framework, right? So this is very framework dependent. Like in React, you have to import React, import render. If you don't know React, this is not very important. If you know, it's quite straightforward. Same for Angular, right? So if you bootstrap an Angular 2 or 4 or whatever, it might look something like this. So here, we actually cannot reuse any code, right? It's very framework specific, which sucks. But let's continue. So we also have a part that we bootstrap Redux, right? And here, it's again, we just call this create store here. In Angular, it looks a little bit different. But the important part is the reducer, right? So remember, reducer includes most of our business logic. So here, I just consider, yes, okay, it's just one line. It's not that hard. Even though it's not very, it doesn't look the same, the reducer part is the important one. So I just give them a check. Cool, so now the last bit is how we actually connect Redux to these frameworks, right? And by the way, here in React, I'm using React Redux. In Angular, I'm using ngrx store, but there's actually smarter alternatives that would make the code more reusable, actually. These are not the examples I'm showing. They're actually both quite popular. I thought the first one was way more popular. It happens that it's not. I actually prefer the second one. So if you're into Vue, there's also Vue Redux-like things. The most popular is Vuex, which is not exactly Redux, but it's very, very similar. And then there was this review that I found out today that was discontinued, and yeah, it's pretty sad because it was awesome. Yeah, so it was more similar to React Redux and to Angular Redux store. Yeah, that sucks. Anyways, let's continue. So binding Redux to the framework. So in React, we use this React Redux, and it has this component called provider, and we use it like this. We just pass the store as a prop. That's it. That's how we bind Redux to React. In Angular, it's a little bit different, but again, we're using this ngrx store, and we just put it as a module, and we pass the reducer. So it's not similar. Yeah, it's quite framework specific, so that sucks. Cool, but then let's do it. Let's see this top level component, right? So in this case, we have to-do app, and in Angular as well, but we actually don't know if this is the same component or not. We'll have to see the code for it. So let's keep this open for now. So at the end, it's not very good, right? It's not looking good. It's not. We cannot reuse a lot of stuff. Just the Redux part. But let's just jump into this to-do app module in both the Angular version and the React version. So the React version could look something like this. The Angular version looks something like this. Let's try to jump right into it. So how do we define this component? And again, this is pretty much component specific. In React, a component is a function that returns JSX. In Angular, a function is this class, so I guess a function as well. But you need to pass this decorator. And they all look, it also returns some kind of HTML. But this is very framework specific, but it's okay, I guess. Oops. So let's see how we bind Redux to the component. So here we have the React Redux also has this function called connect. And notice here that we are using this as a high order component. What it gives us access to is everything about the store, right? It gives us our to-dos, which is our state, and it gives us our action creators as props. So basically this to-do app will have that as props injected. In React is kind of different. So we have to use this dependency injection, which also gives you the store, and then you need to subscribe here to the state. So it sucks a little bit. But the component template is quite similar. I mean, they have different syntaxes, but are not that different, right? So in React, we use map to iterate over an array. In Angular, we use this ng4, but they both look quite HTML-ish code, right? So I guess we can consider that it's kind of the same. So this is, again, not very good, right? It's like we're aiming to write framework-agnostic code, but we're discovering that it's not going very well. But I think we can do better, right? So this gives us time to the second challenge, and here I will just expand a little bit on Redux, because I think there's better ways to write Redux that helps our statement. So we are building like a to-do list app, like a Trello clone that you can kind of like create rows or columns. You can create actions or cards. You can give names. You can assign people to cards. So how could this state look like? So first, I think we have to somehow store the columns, right? And here, this state is a little bit weirder, right? It's not an array. It could be an array, but it's not. And the reason for it, this is a Redux best practice. So I just wanted to give you with a few ways to, if you want to try Redux, maybe experiment trying Redux this way. So this is what I call a dictionary. It's like this store that has an ID as the key, and then the element itself as a value. The advantage being that we can get an item without iterating over an array all over again. So you can see it as like at read time, you can access a given to-do by ID quite fast. Of course, the obvious disadvantage is that it doesn't give the order, right? So that's why we needed to add this index. That sucks a bit. But this is very common, right? It's very common to write your state in a normalized manner. So normalized state looks something like this. But of course, in the UI, in the components, we want a more easier state to work with. So it's very common to have functions like this that kind of change the state and output a state in a better manner, right? And this in Redux is a concept of selector. It just receives the raw state and return a better state somehow. Cool. So we can do the same for the tasks, right? It's just a flat dictionary, IDs. Notice the important bit is that we have a column here, right? A column ID, and that's why it's quite important to get a column by ID, because we might want to like move tasks around, and the only thing we need to do is then change this column ID. Cool. So let's go to step 2. Same as we did before, think about actions. And here I'm not putting all because there's so many actions, but one of them might be to rename to do, which might look something like this. You'll pass an ID and a new name, and this is how the action looks like, quite straightforward. You might also want to have a task like add task to do, right? That you receive the column ID, sorry, add task to column. You might have the column ID and the user ID, and that's it. But this all makes sense when you actually look at the reducers, right? So let's say we have a columns reducer, and whenever the columns reducer, again, look at how the initial state is an object this time and not an array. Whenever we receive this action of rename to do, we just return a new state, right? So we keep everything from the old state except the column with this ID that we receive on the payload, and we just change the name. If you're not very familiar with ES6 or object constructing, this might sound very weird. There's some libraries that make this easier. Cool. So a columns reducer actually doesn't do much. It only handles the columns, not the tasks. But again, if you pass something like this, columns, and pass a Kanban state and an action, so let's say we start with that, and we want to rename the column with this ID. I think it's this one. Currently it's done. After the reducer is over, we have something like this. And again, this is quite nice to test it, right? So another reducer we might want, and you're starting to see how you can break a bigger application apart, is to have different reducers. So here we have a reducer, it's called tasks, and it only handles things related with tasks. Again, it's an object, and whenever we have a type add task to column, we just create a new task, I guess, yeah. So this v4 is just a new ID. We're generating unique IDs. Cool, so we've seen how we can have multiple reducers to break the complexity apart. There's also a way in Redux to combine these reducers together. So there's this function called combine reducers. You also get it from Redux. And again, you end up with a root reducer. So that's how you can break your app apart. At the end, it looks something like this. It's just the columns action is state is just nested into these columns, tasks is just nested into this task state. Cool. So with these weird states, we can actually write more complex selectors, right? So we know that we have our state normalized in that columns are with columns, tasks are with tasks, but we actually want to have on the UI a column with all the column tasks. So we might want to have a selector like this. I don't want to look into the code very much, but whenever we call this selector, it will receive a normalized state like this, and at the end return an easier object to work with. So here is already an array of columns with these field tasks, and then we have the column tasks there. It's a little bit easier to manipulate and to show it on the UI. Cool. So this is the important bit I want to talk about. So there's actually this concept on Redux called dividing the components into presentational components and container components. This is not a new concept. I think most frameworks have this concept even without Redux. Angular comes to my mind. Sometimes it's also called smart and dumb components. So I think presentational components, they care about how things look like. So they are very HTML heavy. Usually it's more for the UI developers, like these guys that write more CSS. They don't know a lot about the business logic. So these guys, they love presentational components, right? Because they don't need to know a lot about the application logic, but they can still be productive. And then the container components, they care how things work, like how the business logic comes to mind. And the presentational components have zero dependencies. They just receive props and return HTML, while container components, they depend on actions and store. And none of them has business logic, because we've seen this on Redux. So again, the first one is more for visual type of developers, the other one is more for interaction. You don't have to do this distinguish, I think it's stupid. Cool, so I think I have to speed up, but let's just try it. Presentational component looks very similar, very simple in React, just receives props, renders done. In React as well, receives props or inputs and outputs and renders a template. So quite easy. Actually no Redux whatsoever at this point. So it actually, the structure is quite different. In React it's a function, in Angular it's class, but it's quite similar, I would say. But I think they share more than they look like in the beginning. They both have inputs and outputs. Of course, in React it's all props, and in Angular it's in input output, but they are the same thing. So I think we can reuse it. And they also notice how they bind these inputs, right? So here the name, just put it under this span. Here as well, exactly similar code. Cool. And also we have to bind events, right? So whenever someone clicked, we just bind to this prop in React. In Angular, we have to emit this event. It's the same concept. Cool, so I think presentational components are awesome, right? So they allow us to reuse a lot, or if you want to redo, we don't have to redo a lot. So let's look at the container components. So again, in React, it might look like this. The code is getting bigger and bigger, I know, but it's almost ending, I promise. This is how it looks like in Angular. So let's do, how do we do the Redux binding? Again, this is the same as we've seen before. In React, is using this connect function. In Angular, is using this dependency injection store. So not reusable. The behavior is quite similar, I would say. I mean, we both call this column components. Remember, the column was this presentational component we just create, and they basically have the same props or inputs or whatever you want to call it. Angular has this syntax, like an event is have to pass it with parentheses. React, everything is a prop, but it's quite similar, right? So it basically connects events or outputs to the store actions. So container component, I mean, it's okay, right? There's of course the bootstrapping part, but it's okay. And I think this is coming to an end. Honestly, when I started doing this, I had more hopes that you could like reuse more things. I think you can still reuse quite a lot. I mean, we didn't see here the business logic, but this is, if you want to have one takeaway from here, is that you can really have this business logic in vanilla JavaScript, whatever vanilla means. Cool, and I just want to finish with 3 points, right? So the web will keep changing, and it will change even faster and faster every year, and so are our tools. And I think framework wars, like that we often engage ourselves into it, I mean, it's really bad. Nobody cares. We just lose time. So let's do less of that. And I think one way to be okay with the fact that the web will change and will keep changing faster and faster is to write or have this mindset of writing framework-agnostic web applications, right? And they help us be at peace with both, in the fact that there will always be a better framework down the line. Yeah, and I think we should all try to write more framework-agnostic code. And I think Redux is a good ally in this journey. And that's it from my side.